Hey guys, today we're going to do piecewise functions. And what a piecewise function is, it's a function that's broken into multiple pieces. And so how this is going to work is part of the graph is going to be the first function, part of the graph is going to be the middle function, and part of the graph is going to be the last function. So we have to kind of break the graph up into pieces and then graph each piece, which is kind of weird. So I'm going to show you how I do these. And what I do when I teach, I use a lot of color coding. And so for a piecewise function, I use 3 different colors plus a pencil. So that's 4 colors total. So 3 different colors plus a pencil. Okay? And I'll kind of keep you, I'll try to remind you what I'm doing and when I'm doing it, which color I'm using, which utensil. That way you can keep track of what I'm doing. And at the end, you'll kind of see why I did what I did. Okay? So the first thing is we have our piecewise function. It tells us where things are. We don't need to worry about that quite yet. We're going to use that as we get through it. So the first thing I want to talk about is this f of x. One thing we should know, f of x is just a fancy way to say y. It's kind of like, I tell my students, it's like y's last name. 90% of the time I go by Jen. Every once in a while I need to go by Mrs. Laughlin. Just depends on where the, if the president walks by the college, then I need to be a little bit more formal. So f of x is the same thing as y. Right? So what I'm going to do is I'm going to take my first color. I'm actually going to start in blue. And I'm going to write down my first equation because I'm going to try to get it away from that piecewise. The way our brains work is as soon as they start to get stressed, they start to shut down. They see this and they're like, oh my God, that's a huge problem. And our brains get stressed, they start to shut down. So what I'm going to do is I'm going to take it away from the huge problem. I'm going to try to work it in bits and pieces. It just allows our brain to relax a little bit and allows it to focus more on the bits rather than getting so overwhelmed by the huge project. So, first equation is y equals 1/2 x minus 1, and that is 4x is less than -2. And I'm just trying to get that whole line away from the large bracket. That way our brain can see this, which is not too bad, instead of this, which is horrible. Okay? Be surprised how much these little mind games actually help us out. To understand how your mind works and how your mind reacts to things will really help you to be able to do your best on your test. Just get everything away from the stressors. Word problems stress you out, get this problem away from the words. Try to make it a little bit nicer for your brain to see. So when we look at these, if you're going to graph piecewise, one thing you should already know how to do is graph a straight line. Any straight line I give you, you should be able to graph. The nice thing about piecewise, it's always going to be set up in y equals. So you're always going to be given y equals mx plus b. So you're not going to have to isolate y, move the x, and divide by anything to get y equals mx plus b. So piecewise, we kind of save you that step. But if you're still struggling with how to graph a straight line, this is going to be an absolute nightmare. So I suggest if you struggle with a straight line, go back and work on graphing just a straight line. Then once you get that down really well, come back to piecewise. Okay? So we're going to start with this one line because I'm going to start by just graphing one straight line. So in my blue pen, I'm going to identify what pieces are here. Now we're going off of y equals mx plus b. So b is always the number without a variable. So it may not always be in the right order, but b is always your y-intercept. That is the number with no variable. So that is going to be 0, -1. I like to always put my intercepts in an ordered pair because that's the first thing I'm going to put on my graph. And so if it's in an ordered pair, it's much more obvious where it goes on the graph, rather than having a random number for y-intercept and a random number for slope and trying to figure out which random number you use first. So intercepts, put them in ordered pairs. It will make your life a little bit easier for graphing. Then the number in front of the x, that's your slope. We use an m to show slope, y equals mx plus b. Slope is 1/2. And the slope is going to be your rise over run. So the way I do rise over run, and some teachers teach it differently, the way I do rise over run is I think of a ladder. So if I'm on a ladder and I'm going in a positive direction, I'm going to be going up. If I'm going in a negative direction, I'm going to be going down. And so for me, when I'm doing rise over run, I always throw this line to the top, if there is one. And if it's positive, it's going up. If it's negative, it's going down. So for this one, it's a positive 1/2. So the numerator is going to be going up 1 unit. Then for the run, I am not the most athletic person out there by any way, shape, or form. I stopped exercising pretty much once I graduated high school. And my exercise is I never stop moving while I teach. So for running, if you ever see me running, you need to run with me. And then you better hope that I'm running in the right direction. Because if I'm running in the wrong direction, then we're all going to be screwed. So when you run, run in the right direction. Run to the right. So when we run, we are going to run to the right. So rise over run, your rise tells you up or down, always run to the right. Right. So, okay. So then we're going to I'm going to switch back to my pencil. So I'm switching back to black. And I'm going to graph this line in pencil. Anytime I'm doing piecewise and I start to graph the lines, I start in pencil when I get to the graph. So I'm going to start at 0, -1. I'm going to label my points because that's a good employee thing. I want to turn something into my boss. I need it to be nice and organized in labels. I want y'all to go ahead and get into the habit of getting things labeled, getting things organized so that when you get to the workforce and you're turning something into your superior, you already are in those habits of having it pretty organized and ready to go. You're not having to go back and, oh man, I forgot to label something, and then your boss is sending it back to you. So 0, -1, and then from this ordered pair, we are going to go up 1 and right 2. That's going to be the ordered pair 2, 0. Okay. Now I draw lines pretty much all day long. That's my job. I teach math every day, all day. That's my life. I cannot draw a straight line with a ruler to save my life. And so what I do, because I know that I'm going to have trouble drawing this line straight, and I don't want it to go completely off once it gets past these 2 points, I'm going to continue using that slope until I get to the edge of the graph. Just to make sure that no matter what, my line's not going to go too far off. So from this point, I'm going to continue to go up 1 over 2. Up 1 over 2. From this point, I'm going backwards. So instead of going up and right, I'm going to do everything the opposite. I'm going to go down and left 2. Down and left 2. Down and left 2. And then no matter how crazy my line gets, it can't go too much because I have the general dots of where it should be. So from this point on, I am pretty much just connecting the dots. And whereas it may not be a perfect line because I made this scale by hand and I'm still graphing it by hand and I am in no way, shape, or form perfect, it's not wrong. It's close enough that without a ruler, I think this is the best I could do. And so, even with a ruler, I can't get much better. All right, so that is this line. But I had this line color-coded as blue, right? Because I did all my writing in blue, and then I switched to pencil to graph the line. So what we need to look at here is we need to look at this restriction. There's a lot of times we are restricted in life by what we're allowed to do. Case in point, when you're driving, you must drive on your side of the road, right? You should drive, at least here in America, on the right side of the road. Now, is that always? No, different countries do different things. If I'm on a one-way road, I can drive on whatever side of the road I want because it's a one-way road. I don't have different traffic. If I'm in England, they travel on the other side. So it's all dependent on where you are, what type of road you're on as to where your restrictions are. So here, this line is restricted by it can only be less than -2 for all of the x values. So what I'm going to do, I'm going to draw a dotted line at x equals -2. That's going to show me where that restriction starts. So when I'm driving around town, I I know in my particular city, I know pretty much which roads start the one-way streets, because I avoid one-way streets. I just personally don't like them. And so I pretty much have this little dotted line around downtown Plano so that I can avoid and say, okay, I'm gonna go over 2 blocks because our downtown's not very big. And that way I avoid all my one-way streets. So in my head, there's a little dotted line that squares all of downtown. So I'm gonna do the same thing here. A little dotted line at x equals -2. So here's my -2, and I'm just gonna do a vertical dotted line. And if you didn't know x equals a number is a vertical line, you might want to put that note here. That is something you need to get memorized. There's only one variable. It's either horizontal or it's vertical. It always intersects the axis that it mentions. Since this mentioned x, it's going to go through the x-axis, so that's going to make it vertical. Okay? Then we know x is going to be less than. So your line, that's our x, your line is going to be less than -2. So if I'm looking at x's, that's going to be left. Left of -2, that's the bigger negative numbers. So that's going to be where it's going less than. So I'm going to take my pencil line, and in my blue marker, I'm going to make it thicker. And this is going to be my actual answer part for the first line. This is blue. Okay? So this part is my actual answer. Now, when it's on -2, you need to determine, does it equal -2? So if we look at this, there's no equals bar underneath that less than sign. No equals bar means it's not equal to. Somewhere I have to show in this graph that it's not equal to -2. The way I'm going to do that is I'm going to put a point, but I'm going to leave it an open circle. Now sometimes, especially if you're only using one color, that can get really busy and it can look full even though it's open. So what I tell my students, if it looks full, just draw an arrow and put that it's open. I'll grade your word instead of your circle because obviously if you can write the word open, you knew it was open. So I don't have a problem with that. But you may want to check with your individual instructor if I'm not your individual instructor. Okay, so the first line is now done. I have a graphed in pencil and then I colored the part that makes my restriction work. Okay, so now I'm going to switch. I'm going to use green for my second line. So my second line, I have y equals 3. So for y equals 3, my restrictions are -2 is less than or equal to x is less than 3 or equal to. Okay, so y equals 3. So when I look at the line y equals 3, there's only one variable. One variable only for any equation is automatically going to be either horizontal or vertical. And the second variable, what it does, y equals 3, it's horizontal because it's going through the y-axis. If there were an x, that x would pull it towards the other axis. Either pull it or push it towards the axis. That's what makes them diagonal. When you think about the x-axis, the x equals that are vertical, the y would pull it towards the axis or push it away one way or the other. That makes them the diagonal lines. So with only one variable, it's either vertical or horizontal, and it intersects the axis that it mentions. So since this mentions a y equals 3, it is going to be, and I'm going to go back in my pencil, because I'm going to graph the entire line. It's going to go through the point 3, 0, or 0, 3, I'm sorry, 0, 3. Okay, and it's going to be a horizontal line. So this point actually should be up there. Okay. Horizontal line. Okay, it's the best horizontal I can do. And so as we look at this line, so that is y equals 3, so I'm going to switch back to my green now so that I can determine what's important. Remember those restrictions. Where are my restrictions? Where am I allowed to go? So this line is allowed to be between -2 and between 3. So what I'm going to do is with my green marker, because I did this line in green, I'm going to go at -2, and I'm going to put a vertical dotted line at -2. And I already have a blue dotted line here, but I'm going to add a little bit of green to it, just because that gives me more of a visual idea what this line is doing. So I'm going to keep the colors with the lines. Okay, so that's at -2. I need another one at 3. So at 3, I'm going to put a second vertical dotted line. Okay. Then my line is going to be between those two. X is in the middle. So your shading is going to be in the middle. So I'm going to take my green marker, and over top of this pencil, I'm going to make it bold with green. I'm going to try to make it 2 to 3 times thicker. If you're only using one color, make it thicker. Somehow we have to be able to tell that this part is your answer, not that part. So if they're the same thickness or the same color or anything like that, where I can't tell the difference, I'm going to say, yeah, you knew how to graph the line, but you didn't know what the piecewise part of it meant. So you're going to lose your piecewise points. Okay? Then we need at the ends. Since these both have equals, equals mean you're going to have closed circles. So right here, you're going to put a dot and you're going to fill it in completely. Put a dot, fill it in completely. If you don't like the way your closed dot works, do just like we did with the open. Draw an arrow and write the word closed. That way, without a shadow of a doubt, we know that you knew it was closed. Okay? So, first line, graph it in pencil. Look at your restriction, do your dotted line, and then shade the part of the dotted line that should be included in the restriction. Second one, graph the line in pencil, look at your restriction, do your dotted lines, shade the part that it should be. Your restriction should normally be less than except for the very last one. What that's going to do is it's going to move your graph from left to right. So the first one's normally on the left. The second one's normally in the middle, or if there's only 2, it'd be on the right. And then the third one, that should be on the right over here. So they're normally set up nice and pretty for you, especially at the lower levels. Maybe once you start getting into the calculus and such, it starts jumping all over the place. But for college algebra, for your entry-level math courses, it's pretty much going to stick to the right order for you. Because our main concern right now is that you can graph it in multiple pieces before we start throwing all sorts of different stuff at you. So my third graph, y equals -2x, I'm going to do it in purple. So y equals -2x, 4x is greater than 3. Okay, y equals -2x, it has no number by itself. It's missing the y-intercept. So if I say there is no y-intercept, that's wrong. I can say there's no number, but there is a y-intercept because there's 2 variables. Remember, one variable is either vertical or horizontal, but 2 variables is going to be a diagonal. So if it diagonalizes, if it is diagonal, then no matter what, it's going to intersect the y-axis somewhere. So the question is where? There's no number there, but I need a number there. It's kind of like if I say I have no cookies. I wish I had some, but I have no cookies. How many cookies do I have? I have 0 cookies. So your y-intercept is 0, 0. It is the origin. Okay. Your slope, always the number in front of x, is -2. Now slope should always be and running, so we're going to put it over 1. Since it's negative, we're going to go down 2 units, and always run to the right. So down 2, right 1. Okay. Back in my pencil, because I'm going to actually put the graph on the paper now. So back in my pencil, I'm going to start at the origin. 0, 0. And then I'm going to move down 2 units and right 1 unit. That gives me 1, -2. Because I can't draw a straight line to save my life, I'm going to keep going. Down 2 over 1. Down 2 over 1, so now I'm at -6. And I'm going to go 1 more because I haven't hit this area yet. I need to make sure it gets in at least the right hand area. So I'm going to go down 2 more and over 1 again. Should put me right around here somewhere. That way at least I know what the line's doing in this area. I'm hoping y'all can see all the way to the bottom. Okay? Do I need to take it backwards? I know that the blue line was over here. The green line was in the middle. So the purple line should be over here. I know the purple line's not going to be over there. So there's no need for me to go backwards in this case. It was necessary on the blue line because I had to get it back over here. And if you gauged it off of only those 2 points, you may have it off over here by the time you draw the line, and then it would be wrong. Okay? So for here, in black, in my pencil, I'm going to draw this line. Barely reaches my 3rd area. My scale's only 5. You might want to make your scale to 10 and it would work a little bit better. And then we're going to do our restriction. So our restrictions, x is greater than 3. So I'm going to do just like before. I want a vertical dotted line. So at 3, I'm going to do a vertical dotted line. And there's a green one already there. I'm just going to add the purple. That way it shows that now I'm working on purples, and purple will start from the purple and go on. And it goes from 3 onward, so I'm going to take my pencil line and in purple, I'm going to color over it. Put my arrow because it goes to infinity. And then I need to figure out, is it an open circle or a closed circle? So I look back at my inequality. No equal sign. Remember, these had equal signs. No equal sign is an open circle, so I'm going to put my open circle here. But I have a lot of stuff going on, so I'm going to just emphasize open. Okay? Now, if you did this on paper, the next step, if you use the same coloring system as mine, the next step would be to erase all your pencil. Once you erase the pencil, the only parts left over will be your colors. And that's going to be what your answer is. For me personally, I just come over here and I say the colors are my answer. And that tells the teacher to grade only the colors. Now again, I'll accept this for my students, but I can't say what all the other teachers in the world will accept. So I like the colors. Some of my students would rather just do it in pencil, and I just tell them to make sure that part of it is bolder. Make sure it's 3 times as thick. Make sure I can tell what your answer is. Because I give them 1 point for graphing the line correctly. That's the pencil graph. And I can tell that if they erase, I can tell if they graphed it correctly or not. And then I give them 1 point for each one for their shading. Did they get the shading in the right spot? Can I tell that that's not an answer, but this is an answer? That this is different than that, that this is different than that. So if I can't tell that, they lose 1 point per line, so that's 3 points. And then the last point I give them is for the open and closed circle. So to me, this is a 7-point problem. 2 points for each line, 1 for being graphed correctly, 1 for the shading, and then 1 point for knowing your open and closed circles, which ones are open and which ones are closed, and being able to tell which ones are open and which ones are closed.